Hello students, and welcome to Lesson 3 of Unit 4. In this lesson, we are going to talk about solving two-step and multi-step equations. Our essential question for today is, how do I solve two-step equations by using inverse operations to isolate the variable? And you remember that in Lesson 1, we learned that this phrase can help us solve any equation. So to solve two-step and multi-step equations, we need to first create a do and undo chart for the algebraic expression. Second, look at the undo side of the chart. It will tell you the inverse operations to use and in what order to use them. Third, perform each inverse operation on the equation to isolate the variable. And remember, when you do perform each inverse operation, what you do to one side, you must do to the other. So let's look at an example. This is a real-world example, and it does not contain the equation that we need, so we will have to write the equation first, then solve it. It reads, Ben charges $7 per hour for the work he completes at his window washing company. He also charges an additional $13 for supplies at each job. If the total bill for his job today was $72.50, how many hours did he work? So if you pull out our keywords here, we see per, which means multiply. So we have $7 per hour, and we don't know how many hours because that's what the question's asking for. So we'll put a variable there. And it says he also gets an additional, which means to add $13, and that his total bill was or equaled $72.50. We put that together to an equation. We have 7 times h plus 13 equals $72.50. So our first step to solving this equation, which is a two-step equation, is to create a do and undo chart for our algebraic expression. Here is our algebraic expression. So we're going to create a do and undo chart for 7 times h plus 13. Well, if you think about if you knew what h was, we would have to take h and multiply it by 7 and then add 13 to it. To undo that, we need to do the inverse operations in a reverse order. So we'll have to subtract 13 from each side, and then instead of multiplying 7, we would divide 7. So let's perform these two inverse operations on this equation. So we're first going to subtract 13 from each side. So subtract 13, subtract 13. Make sure you write the 13 underneath the 72 because those are both the wholes. You can add 0.00 if that helps you. Positive 13, subtract 13 makes 0. So on the left side of our equation, we just have 7 times h left equals 0 minus 0 is 0, 5 minus 0 is 5, 2 minus 3, cancel, so let's regroup as a 10, 12 minus 3 is 9, and 6 minus 1 is 5. Now, our second step in our two-step equation is to divide each side by 7. So divide by 7 and divide by 7. 7 divided by 7 is 1. So we have 1h, or just h, equals, and $59.50 divided by 7. 7 will go into 59 8 times. 8 times 7 is 56. There's 3 left over. Bring the 5 down. 7 will go into 35 5 times. 5 times 7 is 35. So there's nothing left over. Bring down this 0. 7 goes into 0 0 times. Bring our decimal straight up. We got 8.50. So he worked 8.5 hours. So Ben worked 8.5 hours on this job. Now, the rest of our examples today are not real-world examples. They're just standard equations. Because I know that you can write an equation for a real-world situation. This is what our focus is today, just solving. So our next equation says 2 times x minus 1 equals negative 3. We need to write a do and undo chart for our algebraic expression, which is here on the left, that says 2x minus 1. If we look at x is being multiplied by 2, and then that amount is being subtracted by 1. So if we undo that, using inverse operations in the reverse order, we have to add 1 to each side, and then divide by 2. So if we add 1 to each side, negative 1 plus 1 makes 0, and 2x plus 0 is just 2x. Negative 3 plus 1, if you owe 3 and you have 1, then it's negative 2, so 2. So we performed our first step, we added 1 to each side of the equation. Now we need to divide by 2 on each side of the equation. So we divide 2, divide 2. 2 divided by 2 is 1. 1 times x is x. Negative 2 divided by 2. A negative divided positive is a negative. 2 divided by 2 is 1. So x equals negative 1. And you can still take the time to substitute this back in to see if it does make it true. What's 2 times negative 1? Negative 2 minus 1 more, negative 3. So negative 3 equals negative 3, so we know our solution was correct. Alright, our next equation is x divided by 3 minus 4 equals 8. Now notice, this fraction bar or division symbol is not a grouping symbol because there is only one term or one portion of the division on both the numerator and the denominator. Alright, so here's our algebraic expression, x divided by 3 minus 4. So if we knew what x was first, we'd have to divide it by 3 and then subtract 4. So to undo that, use inverse operations in a reverse order. So what's the opposite of negative 4 or subtract 4? Add 4. What's the opposite of divide 3? Times 3. So here are the two steps we need to do to solve this equation. So we need to times each side by 3. We need to add 4 to each side. Getting ahead of myself. Make sure you start at the top of your undo chart. We need to add 4 to each side. Negative 4 plus 4 makes 0. So we get x divided by 3 equals, and 8 plus 4 is 12. Now we'll multiply each side by 3 because that's our second step in undoing this equation. 3 divided by 3 is 1, so we get 1x equals 12 times 3, which is 36. So our solution is 36, and you can check it by substituting back in. 36 divided by 3 is 12. 12 minus 4 is 8. So it does make the equation true. Now, this example is different from the previous one because our fraction bar or our division symbol is a grouping symbol since there are two terms in the numerator. So we're going to create our do and undo chart for this expression, d plus 1 divided by 3. If I knew what d was, I would have to add 1 to it and then divide each side by 3. To undo that, I'm going to go in the reverse order, doing the inverse operations. The opposite of dividing 3 is to times 3, and the opposite of adding 1 is to subtract 1. So the first step I need to do is to multiply each side by 3. So multiply by 3, multiply by 3. 3 divided by 3 is 1, so I'm left with d plus 1 on the left. Negative 6 times 3 is negative 18. Now our second step is to subtract 1 from each side. So positive 1 minus 1 is 0. D plus 0 is just d, so we've now isolated the variable. Negative 18 minus 1 If you owe 18 and you owe 1 more, then you owe 19. So we get negative 19. And we can substitute back in to make sure that makes sense. Negative 19 plus 1 makes negative 18. Negative 18 divided by 3 is negative 6. And if you cannot check your work in your head like that, you can always do it on the side of your paper. Double check. Alright, let's look at this example. I purposely chose this example because the variable is in the second term. So you must be very careful with this situation because this negative sign gets included in this operation. Okay? So we need to write a do and undo chart for this expression, including that negative sign with this term. So we have 3 minus a divided by 7. So if I knew what a was, I would have to divide it by negative 7. So I divide by negative 7. You see I grabbed the sign in front. Then, after I did that, I would have to add 3 because this is a positive 3. To undo that, I'll have to work in a reverse order using inverse operations. The opposite of add 3 is to subtract 3. The opposite of to divide negative 7 is to multiply negative 7. So I'll take this expression, or this equation, and first subtract 3, because this was a positive 3. This is our first step here. What I do to one side, I have to do to the other, so I'm going to subtract 3 from this side. Positive 3 minus 3 makes 0, so I'm left with negative, make sure you bring that sign down, negative a divided by 7 equals negative 2 minus 3, which is negative 5. Now, our second step is to multiply each side by negative 7. A negative times a negative makes a positive, and 7 divided by 7 is 1, so we get positive 1 times a, which is just a, and negative 5 times negative 7. A negative times a negative is a positive, and 7 times 5 is 35. So a is 35. And you can substitute back in to make sure that makes sense. 35 divided by negative 7 would be negative 5. 3 minus 5 is negative 2. Let's look at another example. This example is similar to the last one because the algebraic term is second in the expression. So we have to be careful when we write our do and undo chart. Alright, so we're writing our do and undo chart for 5 minus 9x. And I'm going to put a plus sign in front of the 5 because it's a positive 5. So to do this expression, we would first have to multiply by negative 9. After we multiply the number by negative 9, we'd have to add 5 to it. So to undo that, I'm going to have to work in an do inverse operations in a reverse order. So I have to subtract 5 from each side and then divide by 9. Subtract 5 is the opposite of add 5. Divide 9 is the opposite of multiply 9. So our first step is to subtract 5 from each side. 5 minus 5 makes 0. So we get negative 9x equals, and 50 minus 5 is 45. Now, divide each side by, those should be negative 9. Divide by negative 9. Negative divided negative makes a positive, and 9 divided by 9 is 1. So we get 1x, or just x, equals, and 45 divided negative 9. Positive divided negative is a negative. 45 divided 9 is 5. So we get x is negative 5. And we can substitute back in. Let me show you on paper how to check that. 5 minus 9 times negative 5. Does that equal 50? Well, negative 9 times negative 5 is positive 45. 5 plus 45 does equal 50. So this is the correct solution.